So to find the limit, if you notice, as x goes to infinity, 1 over x goes to 0, and 5 to the x goes to infinity. So we end up with 1 over infinity. And that means that we can use L'Hopital's rule. So when we do 1 to infinity, the L'Hopital's rule that we use before we use L'Hopital's rules, we have to use a little trick, and that's to take the whole limit to e to the ln, because they cancel each other out. So we're going to have e of ln, the limit as x goes to infinity. Okay. And since we're taking the limit, we can reverse the ln in the limit. Okay, and the reason we do that is because now since it's ln, we can bring the 5x to the front. That's using the properties of logs. So now as x goes to infinity, 5 to the x goes to infinity, and 1 over x goes to infinity, so we end up with ln of 1, which is 0. So we end up with infinity times 0. So when that happens, we can use L'Hopital's rule, but we have to change it to a fraction. So what we're going to do is we're going to change the x and write it over 1 over x. Okay. So remember that 1 over x is the same thing as x. Notice that I kept the 5 in the numerator. So now I get 0 over 0, so now I can use L'Hopital's rule. So I'm going to go ahead and take the derivative of the numerator. Okay, the derivative of ln is 1 over u times the derivative of u, and the derivative of 1 over x is negative 1 over x squared. Okay, so notice how those cancel. So as x goes to infinity, 5 goes to 5, 1 goes to 1, and 1 over x goes to 0. So I'm left with e to the 5 over 1, or just e to the 5.